This is a video to show you how to solve FP3 January 2007 question 4. This is a differential equation question. The differential equation they want us to solve is dy dx equals x squared minus y squared over xy. And they give us a hint, and they say try to use a substitution to solve this, and their suggested substitution is y equals xz. Now, we're going to need to swap out dy dx in a minute, and so the first thing I'm going to do is find out what dy dx is in terms of my substitution. So, xz is a product, and don't forget that z is itself a variable, it's not a constant. So when we differentiate this, we get dy dx equals, well, the diff of the first is 1 times the second gives me that z. Then the first x times the diff of the second gives me x dz dx. Now, I can then rewrite my whole differential equation using this substitution and get here z plus x dz dx is equal to x squared, now minus y squared. Now y is xz, so I can write that as x squared z squared, all divided by, well, x times y is going to give me x squared z. Right, I can immediately see that I can cancel x squared from the top and the bottom here, and actually end up with z plus x dz dx is equal to 1 minus z squared over z. Now, I'm going to be able to make some further changes as well, and I'm going to move the z up here to simplify things and subtract the z squared that results. So let's multiply it by z first, keep it straightforward. So I've got z squared plus zx dz dx is equal to 1 minus z squared. Then I'll subtract that z squared and divide through by z to get x dz dx is equal to 1 minus 2z squared now, because I subtracted that z squared, divided by this z, which is what they were asking us to find. That is the differential equation they said we should obtain. Now, they then want us to, having obtained that differential equation, they want us to solve it. So that was part I. We now need to solve this differential equation and show that we're getting, and they give us the result that we're going to require. Now, I'm going to move some things around here. If I need to move all my z's onto the left and x's onto the right, because this equation is solvable by variables separable. So we're going to end up with the integral. Now, if I divide both sides by 1 minus 2z squared over z, I'm going to end up with z over 1 minus 2z squared dz is equal to the integral of 1 over x dx. Now, integrating these are both going to be natural log integrals. That z there would be the this structure here is of the form f prime x over f of x, and we know that integrates to a natural log, and in fact it integrates to minus a quarter log 1 minus 2z squared. And if you're uncertain about where that came from, think about differentiating this now. This natural log here differentiates the inner function here. You're going to get 4z, minus 4z rather. Multiply that by minus a quarter, and you just end up with the z that we need. Differentiate the outer function, natural log, you get 1 over 1 minus 2z squared. That's going to equal, much more simply over here, ln x. Now we need a constant, because we're working with natural logs, let's make our constant a natural log constant, and then we can combine it in a minute. And in fact, at this point, we can write ln 1 minus 2z squared is equal to minus 4 ln cx at that point. And we can even bring in the minus 4 and say that's equal to ln cx to the power minus 4. Now, I'm going to rewrite that to the top of my page over here to make life much clearer. I'm going to rewrite, and then 1 minus 2z squared is equal to ln cx to the minus 4. That's what we just wrote previously. Raise both to the power e, and we get 1 minus 2z squared is equal to cx to the minus 4. Then from here we can substitute out our z squared and get 1 minus 2y squared over x squared is equal to cx to the minus 4. Bring that x across to this side to make life a bit clearer, and we've got x to the 4. Then I'm also going to simplify this by putting it over a common denominator to get x squared minus 2y squared all over x squared is equal to c to the minus 4 at this point. I can cancel power of x squared there and get x squared into x squared minus 2y squared, and change the c to the minus 4 into the k that they suggested, and that is the result they were looking for. Thank you.